Now we can talk about permutations. And if you've been watching all the counting videos in order, the funny thing is permutations have already been covered. We just haven't used the word. In fact, using the fundamental counting principle is almost always a much more efficient way of handling a permutation problem, much better than using the formula. And so if you haven't seen the video on the fundamental counting principle, I'd highly recommend watching those before you watch this video. The fundamental counting principle is the most important principle in all of counting. If you're already comfortable with calculating everything from the fundamental counting principle, then you don't even need to watch this video, although it always helps to have more than one way to review and think about things. If you are not familiar with the other lessons about the fundamental counting principle, again, I highly recommend that you watch those videos before you watch this one. This one will not make a lot of sense if you're not familiar with the fundamental counting principle. One very useful formula, and this is one of the few that it's really worthwhile memorizing, is that if we have n different items and we're going to permutate all n of them, we're going to take n items and put them in as many orders as possible, that's n factorial. That's a useful formula to know. For permutations of k items selected from a larger pool of n items, don't memorize a formula. Instead, use the ideas of the fundamental counting principle. And I want to emphasize here that knowing a formula is not the same as understanding math. Sometimes people think if they memorize all the formulas, they really have a handle on the math. Sometimes memorizing the formula actually impedes your understanding of math, because then you're relying exclusively on the formula rather than understanding everything about the mathematical situation. And so beware of formulas. They're useful in some ways, but don't be over-reliant on them. Here's a permutation problem. Pause the video and then we'll talk about this. From a group of 10 committee members, 3 will be selected randomly. 1 is chair, 1 is treasurer, 1 is secretary. These 3 will form the quote-unquote board of the committee. How many different possible boards can be formed? So for this one, what we're going to do is, instead of using a formula, we're just going to say how many choices for the first person, 10 choices, how many choices for the treasurer, 9 choices, how many choices for the secretary, 8 choices. And we're just going to multiply 10 times 9 times 8. Well, 9 times 8 is 72, times 10, 720. And so we get this directly from the fundamental counting principle without using any formula at all. And that's very important. So that problem was a permutation because, quote, order mattered. In other words, if we pick person A as the chair and then person B for the treasurer, picking them in a reverse order where person B is the chair, person A is the treasurer, that would be a different board. So swapping the people around in a different order actually results in a different board. We know that we use permutations when order matters and combinations when order doesn't matter, but what does it mean for order to matter? How can we decide? And the difference between order matters and order doesn't matter is not simple. There's not a clear, hard and fast rule that we can say, okay, if this is true, then order always matters. If this is true, order never matters. The trouble is that whether order matters or not is fundamentally a right brain question. It's a question about patterns. It's not a logically, follow the recipe kind of question. Left brain is always concerned with what is the right thing to do. Left brain wants a recipe. Give me a clear recipe and I know what to do. That's the left brain. The right brain is about the right way to look at a question. What is the right way to look at a problem? And if you get into that right brain mode, if you look at a problem the right way, then what to do becomes very easy once you're looking at it the right way. And whether order matters or order doesn't matter is very much about the right brain. So it can be a challenge for people who are habitual rule followers and want a rule for everything. So I'll give you some guidelines about order. There are no hard and fast rules, but some general guidelines. If we're counting the number of physical arrangements, so we're putting books on a shelf or or children are sitting in a physical row of chairs, then of course order matters because there's actually a physical place for each thing, and swapping two things in two different places will give us a different order. If roles are specified for each choice, for example, the problem we just had where each role there was a treasurer, there was a chair, there was a secretary, if there are specific roles for each slot, well then order matters also. If choosing elements in different order produces different meaningful outcomes, then order matters. And often it's helpful just to think of, as you're thinking through a problem, what would a few choices look like? And you can't, usually it's not possible to list out every possible choice, but if you list out a few, it gives you a sense of the patterns. Conversely, if choice of individual elements doesn't make any meaningful difference in the final set, then order doesn't matter. So for example, if we're looking at the sum of 3 dice, I roll 3 dice and I'm just finding the sum. Well, order doesn't matter. It doesn't matter which dice hit the ground first or anything like that. All we're doing is just we're adding the sum of the 3. And so one dice had a 2 and another dice had a 6. If we swap those two, we'd still get the same total. So order doesn't matter. Similarly, if there are 10 colored balls and I'm going to pick 3 and put them in my pocket, well, once they're in my pocket, they're all going to be mixed up anyway. And so order doesn't matter. The order in which I pick the balls does not matter. And so you very much have to think about patterns, and you have to think about the actual situation to determine whether order matters or not. Finally, as an overview, permutations versus combinations versus the fundamental counting principle. Remember that the fundamental counting principle is more basic, more flexible, and more widely applicable than either permutations or combinations. And in fact, all the rules of counting, including the permutations formula, including the combinations formula, all of them come from the fundamental counting principle. If you're picking with no repeats and order doesn't matter, then we can use combinations. If you're picking with no repeats and different orders of the final section are meaningfully different, then it's a permutation. Use the fundamental counting principle. And if there are repeats, for example, if we're picking out of a deck or something, and then each time we pick, we shuffle the card back in the deck, and so we could repeat. Any situation like that, then we'd have to use the fundamental counting principle. In other words, if the situation is at all outside of the box, then the combination and the permutation lens is not going to be the appropriate one. You're going to have to go to the much larger lens of the fundamental counting principle.